In this video, we're going to talk about how Python handles dictionaries and sets. So, what is a dictionary? It's an object that stores a collection of data, but unlike a list, it stores them as a pair of keys and values. It's often referred to as a mapping of key to a value, kind of like a mathematical function. The key must be an immutable object. In other words, once you declare it, you can't change it. To receive a specific value, you use the key associated with it. So for creating a dictionary, you say dictionary equals key 1, colon val 1, key 2, colon val 2, and the index into it, the key, can also be of different types. So here we've got name, which is Larry, and age, which is 50. You could also use a number here or something, depending on how you want to use it, but it can get confusing if you're not careful. So how do we receive a value from a dictionary, retrieve it? First of all, the elements in the dictionary are not sorted, so don't assume they are. You retrieve a value from a dictionary by using dict and then the key. So name equals dict name would return the key. If a key in the dictionary is there, it will be returned, its value will be returned. Otherwise, you'll get an exception. So to test to see if a key is in the dictionary, we use in and not. So we say if name in my dict, it'll see if it's anywhere in the dictionary, keys or values, but you can also say if it's in values or if it's in keys by using values or keys. How do we add an additional element to a dictionary? Dictionaries are mutable, so to add a new key value pair, we just say dictionary key equals value. If you worked in other programming languages, it's very similar to a record, just very open and flexible. If a key exists in the dictionary, the value associated will be changed. So, if we already have an email value and we assign it something else, it'll get updated. How do we delete? We delete by saying del and give it the key. How do we get the number of elements? Len is used to name the number of elements in a dictionary. Keys must be immutable, but associated values can be any type of object. One dictionary can include keys of several different immutable types. Values stored in the single dictionary can be of different types. They don't have to match. So, creating an empty dictionary and using a for loop to iterate over the dictionary. To create an empty dictionary, use squiggles, curly braces, use the built-in function dict. There's two ways to do it. Elements can be added to the dictionary as the program executes. Use a for loop to execute over a dictionary. And the format would be for key in dictionary. So let's take a look real quick on how we'd actually go about doing that. All right, so to preload, I've made some stuff here. I've created a dictionary with name and age and city, and you can print it here. I have some code here. Let me uncomment it because I commented it to allow me to work on some other stuff. Oops, it also uncommented my comments. So here, oops, wrong language, sorry. Here is an example of code to access an element and code to remove an element. Okay, so here we go. To access an element, we just say myDict name. You can put a variable in there, no problem. To add an element to the dictionary, we say myDict, like email, equals so on and forth. You can remove it by just saying del my age, and it'll return what you think. And you can add an element with multiple fields. So, for example, dictionary, in our dictionary address, could be its own dictionary. And then we can use a loop that will combine the two items and run through and print out both. So there's some examples on how to actually use it. And we're going to go over a couple alternative methods. We've got the clear method, which deletes all the elements. Get method gets a value, but it won't throw an exception. It'll return this default value. It's an alternative to the bracket operator, but it won't raise an exception. So sometimes it's nice to do that. The items method returns all the dictionary keys and values. We say dictionary.items. It's returned as a dictionary view. Each element in dictionary view is a tuple which contains a key and its value. Use a for loop to iterate over the tuples, And you can use a variable that receives a tuple or use two variables which receive key and index. It's up to you. The keys method returns all the keys as a sequence list. Pop returns the value associated with the specified key and removes that. So we say dictionary.pop key. It will return default if not found. Otherwise, it will find key and return it, return the value, and then remove it. Pop item returns the key value pair and then removes it. And then values returns all the dictionary values as a sequence. You can then use a for loop to iterate over it. And here's just a listing of the various methods. We can also have comprehensions. Dictionary comprehensions that read a sequence of elements and use these input elements to produce a dictionary. So, for example, numbers equals a list, 1, 2, 3, 4, and we create a dictionary, an empty dictionary. For item in numbers times 2, this will give us this dictionary. However, there's a better way to do this, and we can use a comprehension. We could say squares equals, for item in numbers, square the item and then add it to the dictionary. You'll get the same results. Okay, here's the breakdown. We've got the resulting expression and then the iteration expression. The expression iterates over the elements of numbers, in numbers being the list. Each time it iterates, the target variable item is assigned the value of an element, and then we can act on it. At the end of each iteration, an element containing item as the key and item squared as the value is added to the new dictionary. So item is the key, item squared is the value. You can have a list of existing strings and create a dictionary in which the keys are the strings in the list and the values are the length. So for example, we got names, and item will be the name, which is the item, and
here's what I found.
The length of the item. Okay? And this will give us the dictionary we'd expect. So we can also copy a dictionary this way. Dictionary, we say dictionary2 equals K and V, for K and V in dictionary 1 and 2, and it'll create a new list with K and V matching each one of these. You can also use an if in there to restrict your sequence. So we've got this, and we say the largest, if V is greater than 200,000, it will only show those that meet that criteria. Okay, so let's talk a little bit about sets. Sets are objects that store collections of data in the same way as a mathematical set. It's unordered, all methods must be unique, and the elements can be of different data types. Which seems a little weird, but hey, I didn't design the language. A set function is used to create a set. For an empty set, call set. For a non-empty set, call set argument, where argument is an object that contains iterable items, a list, string, or tuple. If argument is a string, each character in that string will become a set element. For sets of strings, you got to pass them as a list. If it contains duplicates, only one of the duplicates will appear in the set. So, getting the number of items is lend. You can use an add method to add items. It will not add duplicates. Sets are mutable, meaning you can change them. Update adds a group of elements to a set. The arguments but see a sequence containing iterable elements, and each of the elements gets added to the set. Remove and discard methods remove the specific item. The item that should be removed is passed to both methods as an argument. When the specified item is not found, remove throws an exception, discard does not. Clear clears all the elements of a set. We can use for in and not in with this loop, just like before. For item in set, the loop iterates once for each element. The in operator can be used to test whether a value exists. Same with not in. We can do unions. Set1 dot union set2. Or you can say, use the or operator. Set1 bar set2. Both techniques return a new set which contains the union. For intersection, you can use the intersection method or just use the and. Set1 and set2, and it'll show a new set which contains the intersection of both sets. How to find the difference? Same thing. Set1 minus 2 or set1 dot difference. Finding the symmetric difference. A symmetric difference is a set that contains the elements that are not shared by the two sets. And for this, we use the caret or hat, or the symmetric difference method. We can also find subsets and supersets. Set A is subset of B if all the elements in set A are included in set B. To determine whether set A is a subset of B, we can use the isSubset method or the less than or equal operator. Similarly, for supersets, we can use isSuperset or the greater than operator. Set comprehensions creates a new set by iterating over the existing one. They're just like other comprehensions for this, but they use curly braces instead of brackets. Set 1 equals, here's my set, item for item in set. We'll copy it into a set. For example, create a set that contains the squares of the numbers stored in another set. Set 1, 2, 3, 4, 5. Item squared for item in set 1 will produce a new set. Okay, we can also use an if statement, just like before. One of the nice things about Python is that it's very orthogonal, meaning many things act the same way. Okay, we can serialize an object. That's convert the object to a stream of bytes that can easily be stored in the file. In Python, for some reason, that's called pickling. To pickle an object, we can import the pickle module and open a file for binary writing. If we call the pickle dump function, pickle.dump, it will write it to a file. You can write more than one. Okay, so now unpickling reads the object back in. To unpickle an object, import the pickle module, open a file for binary reading, and then use load. Close the file. You can unpack multiple objects from the file. Now remember, you have to use the binaries when reading and writing. Let's do a quick example with sets. Let's do some example with sets. Okay, examples with sets. First, let's clear our output window. Okay, so here I've set up a very basic example. We create a set of integers 1, 2, 3, 3, 3, 4, 5, and we create a second set. I don't know why those could contain the same thing, but let's give it a run. Let's actually change this though, just so we can get some more interesting results. There we go. All right, so now if we run it, we'll notice that both sets print and all the duplicates are gone because it acts like a mathematical set. All right, now let's add an item to the set. All right, here we go. Set additional example, we're going to add 6 in set 1, which isn't in there, and then we're going to print it. All right, so let's run this guy. And here we go, it's in the set. Now we're going to add another 6. And if this all works the way we think, we should see no difference. Oops. Okay. Let's run this guy. And now, when we add the duplicate, it doesn't do anything. Okay. I'm going to now go ahead and remove this item from the set. Okay. And we'll just say remove 6. Oops, and I didn't save the file. We'll say remove 6. Okay. Now let's try removing it again and see what happens. It doesn't exist. Let's run this and see what happens. We get a nasty exception. So our options are instead to do instead of discard, we can use, instead of remove, we can say discard. And let's say 0. And we can say val equals. And now if we do this, and we'll print my set. run this guy. And I did something wrong. Oh, whoops, sorry. It returns the default for the type. None. Okay, so it returns none, meaning it didn't find anything. This is better because that way it's easy to fix, to keep your program running without using exceptions. Exceptions tend to be more expensive. All right, so let's do some subsetting. All right, so here is our subset example. All right, we got a subset 1, 2, 3, and we're going to see if it's a subset of my set, which is 1, 2, 3, 4, 5. And so we would expect it to print it is a subset. Okay, let's bring this up a little bit so you can see more of it. Okay, basically, we're going to say subset example, and here we'll print is it a subset. Here we'll use the more convenient form of less than or equal to. Okay, and it says subset is a subset of my subset. Okay. Now let's also do it again, but this time we'll see if it works in the opposite direction. Okay. Change this to subset 2 because I use subset later. 9, 22, 33, and then we can say, and now if we run it, we will see that I didn't compare the new subset. What I do wrong. Okay. Here we go. Now let's run this guy. False, and it's not a subset. Okay. Now we're going to try some union. Okay, I like using the shorthand notation here. I think it's much clearer. So here we've got set 1, union 1 and 2, and we're going to do a here let's say subset. I forgot the superset. And I can't ever type the same thing. I call it their subset. It would be useful if I could type. Let's define our superset. I mean our union. I'm sorry. Let's bring our union here. I mean our superset for our union. Oh, we forgot our superset example. So like we had subset, we'll also do superset. Same thing, this time we use greater than or equal. Okay? So down here, for union, subset, superset, we would expect to get 1, 2, 3. I'm sorry, we get all 1, 2, 3, 4, 5, 6. Let's change it up just a little bit. Let's say we get something that's not in either one. 9, 9, 9. And just see if that makes a difference. It should still be there. Right? Now what we'll want to do is we'll want to do an intersection example. Okay. For our intersection example, we're going to use the and sign to say difference. I don't know, yeah. So let's run our intersection. And here we've got my set and superset have these in common. Okay. And then we will use the set difference example, or symmetric difference, or symmetric intersection. All right. Let's run this guy. And now we're going to get the ones that are not in both. All right, so there we go. And we can go the opposite direction. Or that's in one and not two. Let's go the opposite direction. And again, the same results. Okay, so let's do some list comprehensions real quick, or set comprehensions. Come over here, and we'll build our little set comprehension for x in, notice the squiggles, x in 1 through 10, generate a set of x. And it will, if we run it, give you a quick set. Okay, similarly, for set comprehension, another example with an if statement. Here we go. We're going to say give us only the evens. And works like a charm. Notice, however, that it's not in order because sets are not guaranteed to be in order. Okay, now we're going to take some look at okay, we're going to start a pickling example. So here first, we import pickle. I don't know why this isn't called serialized, but hey, I didn't write the language. So first I'm going to write just a little utility thing so I don't have to keep typing those blasted headers in. Right? All right. And then we're going to first test writing a dictionary to a file. We're going to pickle. Okay. Now, okay, what we're going to do here is not do that because I'm going to put a method. Anyway, here we go. And we're going to open the pickle file that we want to pickle with. And we say WB write binary as file. So it'll close at the end of this. And we're going to say print header dictionary, define our dictionary, and dump it to a file. Right? So now, there you go. Okay, so here's how we pickle it. Now we're also going to unpickle it, put it back in a variable. So let's run this guy. And we get this ran out of input error. Let's do that again. So here, we're going to write our pickle to a file. Okay, we're going to open it and we're going to dump it to a file. And then we're going to write a set. Here we're going to now read the set. Okay, let's save it. And it restores the set. We can also do this instead. We can just loop through and it'll handle it just fine. So you can ignore this return. It's just a deal with the uncommented stuff. Whoops. No, leave it there so it gets out of the loop so we don't do the stuff. All right. And here we give it more advanced stuff. We add dictionary with list, and here it goes. It actually writes it, reads it back in, and all is good with the world. All right. And that'll do it for sets and dictionaries.